So what exactly is Revit? Autodesk Revit is one of many 3D building information modeling authoring softwares. It's developed and owned by Autodesk, and it's utilized by the majority of the architecture, engineering, and construction industry within Australia, as well as throughout North America and Europe. In fact, industry survey states that virtually every large practice in the United States uses Revit to produce its BIM deliverables, with some estimates as high as 90% of US firms and upwards of 80% of firms in the United Kingdom, though Autodesk won't divulge Revit's exact market share. And according to the AIA's biannual report, The Business of Architecture in 2016, 96% of large firms, 72% of mid-sized firms, and 28% of small firms utilized one or more BIM software programs in their deliverables. Revit allows users to design and collaborate, to visualize a building and structure its components in 3 dimensions, whilst annotating the model with 2D drafting elements, and access the building's information from the model's database. Revit allows workflows beyond the 3 dimensions too, with capabilities to plan and track various stages in the building's life cycle, from concept to construction through to maintenance and even decommissioning. So a technical clarification to understand is that BIM is not Revit and Revit is not BIM, although these are often conflated. Building information modeling, or BIM, is the holistic process of creating and managing information for a built asset based on an intelligent model and enabled by a cloud platform. BIM integrates structured multidisciplinary data to produce a digital representation of an asset through its entire life cycle, from planning and design to construction, delivery, and operations. Rather, Revit is one of many building information modeling softwares. In this case, Autodesk Revit supports multidisciplinary design. Taking a closer look at Revit's interface, we can see it's not too dissimilar to other Autodesk softwares such as AutoCAD or Navisworks, and it's broken up into a rather organized structure. So we begin with our common tabs, so obviously starting with file and then architecture, structure, steel, etc., and these may change depending on which plugins you have installed, and you can see this represents a lot of what we commonly see in software such as AutoCAD. The ribbon is then underneath those tabs, and the ribbon is responsive to whatever tab that you are currently selected. So under the architecture tab, for instance, we have wall, door, window, floor, ceiling, rail, etc. Structure denotes anything for obviously structural elements, beams, walls, rebar, etc. The systems tab is really denoted for your typical engineering or MEP solutions such as electrical or plumbing or mechanical. And then the annotate tab is typical of any 2D drafting conventions that you'll utilize. These are just a sample of many different tabs within Revit. We then move into our main modeling window. So this is not too dissimilar to model space within AutoCAD, but within Revit, we are working within the 3D and the 2-dimension realm at the same time. We can open up multiple modeling windows, or we can just have one maximized window as you're seeing here. We then move on to the project browser, and the project browser is a really important tool where we can go through the different views of the project, including legends and also schedules, etc. But then we also see sheets, and we also have a list, the full organizational structure of all the families, groups, linked models, everything within one area, which is known as the project browser. We then have our properties window, which is not too dissimilar again to AutoCAD or Navisworks, where it's again responsive to whatever is selected. So in this instance, nothing in the view is selected, so it's giving me the properties, or it's giving me the intel for the view itself. However, if you're to select an object, it will then report the metadata on that particular object. So just like any other software or platform, there are key concepts and definitions that one needs to understand to fully grasp the platform and utilize it in an intuitive fashion. And so within Revit, there's a couple of concepts that we'll cover here, beginning with categories. So in Revit, we use categories instead of layers. Revit does not use a layering system, unlike other CAD softwares. Categories are broken up into different structures. So the first one being model-based categories. So you can think of that as anything that is three-dimensional within your project is a model category. You then have annotation categories, which is anything that is two-dimensional. You then have analytical categories, which is essentially an analysis-based model that determines points and lines and loads of elements for structural analysis. And then we have imported categories as well. So these could be imported CAD files and their associated layers within a CAD file, both 2D and 3D, or IFC files, or any other foreign file that's imported into your project. And so categories are really are the means of organization, selection, filtering, and editing within Revit. And categories are fixed. You can't create new categories, and you cannot delete existing ones, even if you're not utilizing them. You can, however, create custom subcategories underneath these primary categories. So taking a look at model categories a little bit closer, as I alluded to before, they're based upon 3D objects. So we can think of doors, walls, floors, ceilings, etc. If we look at some of these categories and the items that may fit within them, the furniture category will have sofas, desks, chairs, and cabinets. So you won't have categories per se for each of those, but you could create a subcategory for each of those. But commonly, sofas, desks, chairs, you would click on those and they would all just say they come under the furniture category as one example. Plumbing fixtures would have showers, taps, baths, and toilets. While casework will have built-in joinery, vanity units, or kitchen cabinetry as an example. Annotation categories are, again, 2D based objects. So these would be, think of items such as dimensions, tags, text, levels, grids, section markers as some examples. I mean, they go on in a much more comprehensive fashion than that, but it's essentially what they are. And then moving on to another concept known as Revit families. So within Revit, families essentially are a group of elements within a common set of properties called parameters and related graphical representation. I think really an easier way to think of families are essentially in AutoCAD and Rhino and other softwares we have blocks. Revit, we have families. That's essentially the difference. Families are still organized by those categories. So, a sofa can be a furniture family and a side table can be a furniture family as well. And then you've got door families and walls and, all sorts of other objects. Families that have other families embedded within them are called nested families. Sometimes they're called superfamilies as well, but commonly nested. A good example of that would be like a vanity unit with a sink and a tap. That is a nested family. And so there are three different types of families within Revit. So firstly, you have your system-based family. So that's doors, walls, ceilings, etc. These are families that can't be created outside of the project environment. You can transfer them between projects, but you can't necessarily create them in an external environment and bring them in. That is more of your loadable families. So think of doors, sinks, furniture, stuff like that. These are items that you build in the modeling environment or the family environment outside the project. And then you bring them into your current project. And then finally, you have in-place families, which is kind of like you have the ability to build off any of those categories of families within the actual project environment. This is typically reserved for unique one-off items. However, as it's just not good organization, or it's not expedient to be modeling complex families and geometry within the modeling environment, you might as well do them in another family and then load them into your project. And then finally, looking at parameters. That's the other key concept to understand within Revit. So parameters, really, they are the information in BIM. They store information which can then be scheduled or exported to other applications or viewed as properties of an object, such as like the height of a wall or the width of a door. Parameters, a parameter is a setting that determines the appearance or behavior of an element, or it can even be a type or a view. And again, in simple terms, parameters are like a question. So a parameter is created, and then you answer that question later on. Like for instance, door width question is 820, or it is 920, or whatever it may be. And so those questions come in two types. So you have a type-based parameter, which essentially means you change one parameter or the value or the answer of that parameter. It changes all of them for that type of family. Or you have an instance-based parameter, which is change one means it only changes that one object that you have selected. So a good analogy I like to use here is think of, you have a 820 door, and then you want to make a 920 door. Typically, they are two different types of doors, so they are more likely to be type-based parameters. The width of a door is to be type-based. This type is 820, another type is 920. But instance-based parameters that can be shared between the two might be something like the handle type. So you might have two of the exact same 820 family types, but you will have an instance parameter for the type of door handle. So one might be like a passage lever and the other one might be a lock lever. And so both of them are the same type of door, 820, but they both have different types of or instances of levers. So that is an instance parameter versus a type-based parameter.